Okay, today we are adding like terms. So we're going to use algebra tiles to represent like terms, and your practice will be in the textbook, page 254, or the course notes, or we have some That Quiz and Manga High to try. This is all going to be on Edmodo. Alright, so we have this problem, the pool noodle perimeter problem. I'm collecting like terms here. So we don't know the dimensions of this pool. It is a rectangle, but we want it to fit 6 people side by side in 5 rows. And they're going to be doing water aerobics. So what we're going to do, since you use pool noodles for water aerobics, is we're going to put down some pool noodles to figure out how wide our pool needs to be. So there's one pool noodle, and of course I'm going to fit side by side pool noodle after pool noodle. Now all the pool noodles you can see are all the same length. So since they're all the same length, we'll use the same variable for each. So we don't know the length, but we do know they're all the same. So that means I can use a variable. And in this case, I think I'm going to use the variable P to stand for pool noodle. So the variable will be P. So once I've labeled all of these, I actually know that I have 1, 2, 3, 4, 5 P's along the width of the pool, and 1, 2, 3, 4, 5, 6 P's along the length of the pool. So I can write that as 6P, or 6 times P, and down below 5P. Now since this is a rectangle, that means I can find the perimeter by just adding all the lengths. So the perimeter is going to be equal to, adding the width of 5 P's plus the length of 6 P's, and then I actually need to do that twice because I have this width and I have the width back here, and I have this length of 6P, and I have this length 6P over here. So I'm going to multiply all of that by 2. Of course, I can count all the P's, and it turns out that I have 5 and 6 is 11, and 5 and 6 is another 11. So I have 22 P's, or 22 pool noodles, is the length. So what do you think is the perimeter of this pool? This time they've used X as the length of a pool noodle, which we don't know, but they also know that this section right here is 2 feet in length. So what do you think is the perimeter of this pool? Pause the video and discuss. Okay, we can also use algebra tiles to represent unknowns. So on Friday we saw that we could use the tiles X and the other rectangular tiles negative X to represent the opposite. And we know that if we have a positive X and a negative X, we know that those two create a 0. So we're going to use the 0 principle here. So the first thing we'll need to do is we will need to create x squared. So I'm going to take an x squared here. I will need 3 x's. 1, 2, 3, and I'll need 5 ones. 1, I'm also going to need to represent this 2x squared minus 4x, and I'll do that down below. So I still need 2 positive x squareds, but this time I need 4 of the negative x's, and I need 1 of the negative 1s. Now, we remember from when we were adding integers that if we had a plus, this was just like combine. So I really want to pile all of these together. So I'm going to take this pile, I'm going to stick it down with the other pile, and now I'm going to see what zeros I can create. So let's see. I wouldn't count these x's with the x squareds because they're not the same kind of tiles. So they're not like terms. So putting these all together, I see that I have 3 x squares I have 1, 2, 3 x's, but I also have 4 negative x's. So I actually create 3 zero pairs here, and I just have 1 negative x left. So there's a negative x, whoops, that's not an x, a negative x, and I see that 1 positive and 1 negative cancel out to make a zero pair, so I will have 4 left as well. So I will write this then as 3x squared minus x plus 4. And again, I wouldn't combine these tiles together because they're not the same kind of tile. So that's why I have to write them separately. There they are. These are not the same kind of tile, so I'm going to write them separately with their name. And I use my zero principle. So I was using the ExploreLearning edition of Polynomials Activity B app, and you can log in and use the Edmodo account to find the link for that. But we have another example here of negative 2x squared plus minus 3x plus 2, and that's added to the other terms of 2x squared plus x plus 5. And again, I can't, even though these are in the brackets, I can't put the x and the 5 together because these are different kinds of tiles. So that's the goal of our work today, is to make sure you can tell the difference between a like term and a not like term and combine them using the zero principle. Okay, we'll see you guys tomorrow.